All right, perfect. So again, first of all, I welcome everyone to today's session. And again, at any point of time, if you have any questions, feel free to ask. We'll try to keep this as a really kind of a very informative, of course, and also a very interactive session. So this session is actually meant for beginners. So you don't need to have any sort of prerequisite knowledge as such. Of course, I mean, if you do just know what exactly is machine learning, you just know the term machine learning, that should be good enough. But of course, we'll be sharing everything today. It's absolutely for beginners. So in case you have any kind of questions, feel free to ask at any point of time, and I would love to take up any of your questions today. But yes, we'll officially kick it off. We are already 5 minutes into the session, and we have a good number of people already joining in. Again, at any point of time, use the chat section to ask your questions, and also do share about this session with others if you want to actually, if you actually do like any of the information that we share today in today's session. Feel free to also go ahead and share it with others on Twitter, on LinkedIn, because ultimately why are we keeping this session is for to share the knowledge about this topic of TensorFlow.js, and the more we share it with others in public, the better it is, right? So yeah, without wasting any further time, let's get started. So today's session for a Codementor series is machine learning for the web, introduction to TensorFlow.js. So what we're really going to be covering is that how can you actually take two really important and two very widespread areas of software development, one being web development. That's mostly you're using JavaScript, both for front end, back end, right? A lot of you might be web developers, and a lot of you might also have tried your hands on machine learning, which usually it's categorized as a very research oriented and a very Python friendly stream of computer science mathematics, right? So today we're going to be seeing how you can actually intersect both of them and actually create really fun applications with just the help of JavaScript. So a very quick introduction about myself. I'm Shivay. I'm a software developer by trade, but I'm also a TensorFlow.js special interest group and a working group member from India. So as part of that, I take a lot of sessions on TensorFlow.js. I educate and mentor students and also working professionals on getting started with TensorFlow.js. Apart from that, I have been involved with a number of open source programs like Google Summer of Code, where I've basically mentored within TensorFlow, specifically for the TensorFlow.js project. And I'm also a organizer for TensorFlow user group, New Delhi, which is essentially it's a entire meetup group dedicated for organizing TensorFlow related activities. And there are user groups, TensorFlow user groups around the world. So if you're interested in machine learning, I'll recommend you to check out the TensorFlow user group that is local to your area, and try to register for it, and you can attend some events from TensorFlow over there. But yes, without wasting any further time, let's get started. So I mean, before we get into first of all, why machine learning within JavaScript, and we talk about TensorFlow, of course I'll just like to give a very quick recap on what exactly is machine learning, right? So of course, I mean, the traditional sense in which computers operate is that you give an input, and basically the operation that the computer is supposed to perform, and it will perform that operation and it will render the output. But with machine learning, essentially what we are doing is that we are giving human-like intelligence to the machines. That could be a computer, it could be an Arduino device, and we expect that whenever we give some kind of an input to the computer that has that human-like intelligence from the machine learning inference, it is able to actually decode what exactly is the context for the data, and then it will try to predict based on certain scenarios, right? So we see machine learning all around us. We see machine learning right now live, that you can actually see my face. So what is happening is that Codementor site gives me this background, being able to actually blur my background. That is actually an application of machine learning. We see fake news detection. Like, there are so many different things that you can actually do with machine learning. So the idea is that now you would want to actually bring machine learning to JavaScript, and of course we'll talk more about why, the question, because the biggest question is why. especially for all the web developers who are joining in today. They might be wondering, like, why machine learning for JavaScript developers? So that's what we'll be answering. But just to sort of also give a very quick introduction about TensorFlow itself. So for those folks who might be interested in knowing what exactly is a TensorFlow, so TensorFlow is essentially an open source machine learning library. It's essentially a framework that is created by the team at Google, and it's mainly used for high computational machine learning, especially computer vision tasks. So essentially, internally, what it does is that it has really large tensors. So tensors are essentially very large vectors that contain matrices, and these vectors essentially contain various numbers, and they undergo different type of calculations to predict something, right? So just in a nutshell, we'll not really go too deep into what exactly TensorFlow does, but in a nutshell, what we are essentially doing is that whenever you talk about machine learning, all of your data that you might have gets converted into a mathematical format. So all these calculations that are being done are being represented in these really huge tensors. These are really big n-dimensional arrays, n-dimensional vectors that undergo some changes, and those changes result in the machine learning operations. So coming to the first question, that why machine learning in JavaScript? So first, I would like to just highlight some of the great points that come with JavaScript, right? So JavaScript is a very versatile language. It can run on the browser, it can run on the server side, it can run on desktop, it can run on mobile devices, on IoT devices, and we just explore some of those different platforms. For instance, on browsers, JavaScript is supported on all the modern web browsers. While on server side, you can use JavaScript with Node.js, which is a backend framework that with which you can actually create backend applications. With mobile, you get support for React Native, which is a mobile full stack cross-platform mobile application development platform. You can use JavaScript within that, and then of course for desktop you have Electron.js. And for IoT, if you're actually also interested in any kind of a low powered devices, especially with Raspberry Pi, there are direct embeddings for Node.js. So you can actually create your functions and create applications programs directly for Raspberry Pi with Node.js. And one of the biggest reasons why we want to actually introduce machine learning within JavaScript, one of the other reasons being that if we actually look at one of these developer surveys provided by Stack Overflow, so JavaScript is easily one of the most popular languages in terms of the usage, right? In terms of the responses that Stack Overflow got. And there's a good reason for that. A lot of developers today use JavaScript because it is a relatively easy language to get started with. By no means it's easy, right? But it's one of the languages that is having so much documentation that it is relatively easy to actually get into the JavaScript ecosystem just because of the number of resources. So generally, whenever we talk about machine learning, as I mentioned, right, that most of the programs or most of the implementation that you'll see is usually either in Python, or you might see in other languages such as Julia or R, which are more sort of research and statistics oriented. With Python, you get the ability to actually create machine learning models. You can deploy your machine learning models using frameworks such as Django. These are like backend frameworks, Flask or Django. But the question is then, why introduce machine learning for JavaScript? So the biggest reason is that with the help of TensorFlow.js, that which we are actually going to be talking about, we can actually go ahead and utilize machine learning within JavaScript. And for that, you don't need to actually learn, let's say, additional languages such as Python to be able to implement machine learning, because this is something that even when before TensorFlow.js was actually officially released, I was also both a JavaScript and a Python developer. And if I wanted to, let's say, include a JavaScript, machine learning model inside of my project, I would have to host a separate server of a Flask server or a Django server, and then communicate those API calls from, let's say, a Node server back to my Django server and communicate the results. And that just created extra dependencies. And especially if you are from the JavaScript ecosystem, there's a good chance that you are very well versed into JavaScript. So that is why the need for being able to actually run and create machine learning models and run them within JavaScript was the need of the hour, and that's what gave a rise to this concept of TensorFlow.js, which is essentially again like TensorFlow, an open source machine learning library written in JavaScript, again provided by Google. And there are multiple ways in which you can actually get started with TensorFlow.js, and today we will be exploring some of these different options that are out there for you to actually choose. So whether you are a complete beginner in the world of machine learning, or you already are very well versed with machine learning with JavaScript, or you might be a Python developer, we'll be looking at the various ways in which you can actually today run machine learning models within JavaScript. So this particular section is something that is going to be extremely informative, and I hope that you're able to get something out of this particular section. But of course, one of the other reasons why the need for TensorFlow.js was introduced was that today a lot of creative programmers, creative developers, creative professionals who might not have computer science knowledge, they might just be using, let's say, simple JavaScript, HTML, CSS for creating some fun applications. They can even actually use TensorFlow.js because there are some very beginner-friendly, ready-to-use models that are really that can be used by these creative professionals. So if you have let's say absolutely no knowledge about machine learning, or you're a beginner, you can still utilize these machine learning models inside of your applications and create really fun projects. So if you're even a student, right, you want to let's say you're attending a hackathon, attending a hackathon, so you can actually utilize TensorFlow.js with your web project and have no knowledge about machine learning and still be able to actually create some really compelling and some really amazing applications that will actually showcase some of the examples as we uncover some of those projects today. By the way, Abhishek is saying that he was actually using Flask today. So as I mentioned, right, that a lot of you might actually come in from a JavaScript or from a Python background, and usually the most popular way of actually deploying a machine learning model, if you're using it with a web application, used to be Flask or Django from a Python background. Of course, Abhishek, I'll be answering your next question as we also explore. And one of the other reasons why you might actually want to use JavaScript alongside machine learning is the fact that JavaScript has a huge ecosystem that you can actually create augmented reality applications. You can create VR based applications. You can do things like being able to actually connect Bluetooth. So we have web drivers for Bluetooth that can actually get connected with JavaScript. And you can do things like accessible applications, conversational AI. All of these are possible with the help of JavaScript. So it's just a matter of fact that you can also then include machine learning within all of these different applications as well to further aid and further build your applications. So coming to probably the most interesting part of our entire presentation today. So as I mentioned that whether you are an absolute beginner with machine learning or you are a machine learning pro, you already know how to actually write machine learning models. There are multiple ways that the TensorFlow.js ecosystem actually allows you to go ahead and utilize TensorFlow.js to be able to actually use machine learning models with JavaScript. So there are broadly 3 different categories, and we'll be exploring all of these 3 different categories and also go through some code samples, code examples, so that you can actually get to know how you can actually use them. So the first one is running existing models. So this is really the way that is provided by TensorFlow.js to be able to actually go ahead and without having any knowledge about TensorFlow.js or without having any knowledge about TensorFlow, you can just use some starter functions and embed them directly into your program and start using them. That's how easily you can actually go ahead and do them. Apart from that, let's say if you come in from a Python background, you can basically take your Python based machine learning models and actually convert them into JavaScript based machine learning models and directly use them within your JavaScript function. Again, we'll be showing you how you can actually accomplish that. So I'll definitely recommend to all of you to stay tuned, because some of these examples we'll be exploring towards the end of the session and some of them we'll be taking up in the middle of the session as well. So I'll recommend to all of you to stay till the end of the session. And then, of course, in case you have some machine learning models in TensorFlow Hub, TensorFlow Lite. TensorFlow Lite is basically a way to actually have very small machine learning models, usually typically meant for, like, let's say IoT based devices or mobile devices, or like, let's say Onyx. So all of these can actually get converted into TensorFlow.js that allows you to actually run your machine learning models within JavaScript. So you have this entire ecosystem of being able to actually convert models that were previously written in languages such as Python, or you have some pre-existing models that we'll be taking a look at. So that some of the ones that I actually like to showcase, for which you can actually go to the website known as TensorFlow.js.org, TensorFlow.org/js. So let me actually go ahead and share this particular screen. So I just share my entire screen over here. So basically, this is the website, and over here you'll find a number of different pre-existing models. So essentially, for these pre-trained models, right? So these are already existing models that you can directly just go ahead, copy, and utilize inside of your JavaScript code. So some of these pre-existing models, and again, it ranges for a number of different applications. So if you want to do things like computer vision, so if you want to do things like image recognition, image object detection, recognition, if you have some applications related to human body, so you want to do some kind of pose estimation, it could be probably used for, like, trying to detect what kind of yoga pose you're actually doing. If you want to use things for NLP, which is like natural language processing, so there are a number of different models, and these are just some of them. And you can actually go ahead and actually explore all the different kind of models that are existing today. So for instance, if you are willing to actually, like, go ahead and try to classify images, that what is the category of the images. So you can see all of these pre-existing models, and you can actually go ahead and see the code for them on GitHub, because TensorFlow.js, as I mentioned, is an open source library. So you can contribute, and you can, look at all of the code base. It's completely available on GitHub. So over here, there's the example for the MobileNet, which is a very simple machine learning model to be able to predict what is the class of the image. So over here, you can see that within, this is probably 5 to 6 lines of code. We simply just load the model, and we use the classify function. So this classify function essentially takes your image, and it will make a prediction that, okay, in, like, let's say if you put an image of a dog, so it will try to classify, okay, that this is an image of a dog. It will basically make that classification, and you can see that uses simply console log whatever predictions the model is actually doing. So the two words that we'll probably use a lot today is classify and predict. So classify is essentially, like, we are telling the model to try to predict what is essentially the class. Or, so for example, like, let's say if you create a machine learning model to try to predict whether, an image contains an image of a dog or a cat, so it will try to classify whether that image has an image of a dog or cat. And the other one is prediction, because that's what is the end output that we receive from this machine learning model. So you can see that within 5 to 6 lines, without having to know that what's going on behind, what is the mathematics that is going on behind, you can very simply just utilize this, right? And we'll be seeing some examples today as we explore the depths of TensorFlow.js. And again, at any point of time, if you have any questions, feel free to ask. So one of the questions is, most of the examples use CocoSSD. How you can actually build your own classification? So this is a really great question. As we explore, so actually today's demonstration that we are going to be showing is actually based on the CocoSSD. But I'll also share how you can actually create your own classification model if you're, like, let's say, not wanting to actually use the pre-existing CocoSSD model that is already provided. So over here you can find the CocoSSD that is actually used to create a bounding box in front of an image that we are which we present to it. So, like, let's say in case an image contains an image of a human, and it also contains like a table. So the machine learning model, the CocoSSD model, will be able to localize and create like a bounding box, and predict that, okay, there is an table and an image of a person inside of that particular image that you give to it. So I'll basically come back to your question by sharing that how you can actually also build your own custom co-SSD model where you can expand upon that model. So I'll come back to your question, but it's a really great question. But I hope that so far everyone is able to actually able to understand. So again, at any point of time, if you have any questions, feel free to ask. And of course, if you are liking the session so far, please just I would love that if you could acknowledge, and so that I'm also content that everyone is able to follow along so far. And in case I'm going too fast, do please let me know. I'll try to slow down a bit. But that is some of the pre-existing models that you can actually directly use. So if you have absolutely no knowledge of machine learning, it's as simple as just going ahead, copying this code and pasting into your JavaScript file, and just utilizing, of course, just the bare minimums to start creating, let's say, an object detection, object recognition model. And then of course there are so many other different type of models. And that's what we are just I like to share some of the existing ones. For example, the one that one of you shared was about the Coco SSD. So this is an example that within the image, it is able to actually predict and localize separate objects within an image and create a bounding box and share confidence score that the machine learning model is confident, 98% confident that this actually is a dog within this frame. And it has been trained for over 90 different classes. Then we have face mesh, which basically creates these 468 different landmarks on your face, and you can create some really cool applications with it. So L'Oreal actually uses this application within their mobile application, which essentially you're able to try out a virtual lipstick, which uses the face mesh model, using which it is able to localize your lips. So essentially each and every part of your face is given a separate X and Y coordinate, and using the coordinates for let's say your lip, it will be able to find out where are the coordinates for the lip, and it will be you can create applications like these. Then we have something like body segmentation that allows you to actually distinguish human bodies within a particular frame, and this actually happens in real time. And some of them today are that we have actually launched recently within the TensorFlow.js ecosystem. So things like selfie depth estimation. Some of you, if you use the Google Photos, you might have actually seen this really cool video based, where if you just take a static picture, you're actually able to see a 3D animation of that image. I don't have an live example to show that right now, but you might have actually come across recently if you use Google Photos. Then actually this is the example that you might have actually seen with just the static image. You're able to actually create something like this as well. And if you actually want to try out, you can take a look at the link that we have over here, and I'll be also sharing the slides later on. Then we have something like some really cool effects that you can actually use. So this actually uses things like 3JS for 3D rendering, 3D animation. And we have being able to actually detect live pose. This could if you want to let's say count how many reps you're doing, exercise reps, you could actually create a JavaScript application. And today within production, right, today a lot of startups, and especially healthcare startups, are actually using TensorFlow.js to do things like being able to count how many reps you're doing, to try to predict whether you are actually doing a particular exercise correctly or not, by being able to look at all of these different landmarks of your body, and then trying to compare as you do an exercise whether you're doing them in the right angle or not. And then you can do something really cool such as VTubers, which today are becoming quite famous. You can create your own VTuber using TensorFlow.js as well. And some of the other examples are that you can actually combine multiple of these effects to create something by using let's say WebGL shaders with TensorFlow.js. You can create these virtual lasers. You could use multiple concepts within JavaScript. So we hear Jason Mays, who's a senior developer advocate for TensorFlow.js, used WebRTC, A-Frame, which is used for AR, augmented reality, 3JS, and TensorFlow.js to basically create a teleported version of himself somewhere else, right? So you can basically do a number of these different kind of creative applications with the help of TensorFlow.js. And so I mean, again, since the entire landscape of JavaScript is so vast that you can just use machine learning, TensorFlow.js with AR, VR within JavaScript, or just simple plain JavaScript as well. So that's the context, or that's the extent to which you can actually utilize JavaScript. And then of course coming to the next type. So of course in the first part that we covered was using actually pre-existing models. So the first part that we covered was being able to actually run some pre-existing models that are already provided to you. The next one that we are actually going to talk about is how you can actually retrain existing models, and that is what is known as transfer learning. And again, till then, if anyone has any questions, feel free to ask. So one of the questions by Abhishek is why 468? Your question is particularly in correlation to the landmarks, right? The facial landmarks. So essentially, that's how the calculation has been done. That for this face mesh machine learning model that we have, how it operates, as I mentioned, is that there are 468 different points or coordinates on the entire face that it is able to actually map to, and each coordinate is given of course it will have a separate x and y coordinate, and each of these landmarks have been utilized to cover any kind of facial expression or facial thing that you can actually do. So you could create 3D face masks, whatever you want, you can actually accomplish with that, to track eye movement, to track mouth movement, just to so by default that's the number. But of course if you let's say create your own machine learning model that might have, let's say, more number of landmarks, then of course you can create even more number of complex use cases. You could try to even even if I'm let's say having a very small movement of my lip, you could probably try to track that. But again, it kind of becomes slightly more difficult to be able to do that. So by no means it's not possible to do that. You can do it, of course. That will increase your overall accuracy, but at the same time, if you have so many number of landmarks, yeah, by default the calculation is done using 468 landmarks. You could increase, but again it will just increase the complexity of the project as well. I hope that answers the question. But of course, the next one that we're going to be talking about is basically the ability to actually retrain some existing models. So let's say the one of the ways in which machine learning actually works is that you might already have an existing model, and you might actually want to make that model specific to your own data. So usually whenever we create and train a machine learning model, it is usually done on an existing set of data. So essentially the model adapts itself to the data that is being given to it, and that's how we are able to actually train our model and utilize that model. But let's say that you want to actually go ahead and use an existing model and then retrain that model on your own data. So how can you actually do that? So within TensorFlow.js, we have a concept known as a teachable machine, which essentially, again, behind the scenes is using something known as neural networks. And this will take the existing neural network and then train itself on the data that you provide to it. So I'll be showing you an example for the teachable machine. So I'll quickly go to the teachable machine website and show how it actually works. So over here, essentially you can build a project on an image project, audio, or pose. For this example, I'll be showing you on the image project. So what we'll do is we'll basically create a very simple example where I will basically create two different classes. So the model that I want to train is that I want to create a very simple image model which will be able to predict whether I have a phone with me or whether I have a let's say a bottle with me, a simple water bottle. So let's say we create two different classes. So one is a water bottle, right? Water bottle, and the next one that we have is a mobile phone. So what we'll do is that we'll basically give our image data, because of course whenever you work with machine learning you have to give it some kind of a data. So we'll start off by giving it the image data for using the webcam. So I'll go ahead and open up my webcam, and I'll very quickly just hold this particular bottle in front of me. So let's see if it is able to actually detect the bottle. Let's see. Give me just 1 second. All right, so it should be allowed. Hold to record. All right. So let's see if it is able to actually find this particular bottle. Okay, there appears to be a issue with my camera. Let's see if it is able to relook it again. Just give me 1 second. Let's see. So I'll switch over to this camera. Let's see if it is able to. Yeah, perfect. So over here, I'm holding a water bottle, and what I'll do is I will basically take some sample images of this data. Now, one thing to keep in mind is that more the number of images, or basically the more that you train your model, the better it is for for the machine learning model, because the more amount of data that you actually give to your machine learning model, the better it is for the training process. So essentially, again, the main reason being that if you have more amount of data that you give to your machine learning model, it is able to find out more number of insights from the data that we're actually giving to it. So the first the first class that we have given approximately 123 image samples. So for the next one that we are going to be having, I'll just simply go ahead and put my phone in front of the camera, and we'll take 100 and let's say approximately 120 different samples. So let's say that 120 is fine. It should be good enough. And I'll call this particular one as an phone. So this is for our phone, and this is for the water bottle. All right, perfect. Now what we'll do is we'll go ahead and actually click on train this model, because essentially we are giving it these two specific image classes, which is the water bottle. And as you can see that the training has already begun. So what is happening behind the scenes is that it already has a machine learning model, which is a deep learning neural network, which is mainly used for deep learning. And it is basically retraining itself on the new data that we have given to it. Now, for example, it has already trained and it is actually ready to be tested. So let's say if I bring my bottle in front, so you can see that it is able to predict very easily that for most number of cases, it is giving almost like 90+% confidence that this is actually a water bottle. Now let's say if I bring my phone towards it, as you can see that it gives almost 100% prediction that yes, I'm holding a phone in front of the camera that I have. Right. So essentially, as you can see, this way we have created this machine learning model, right? And very easily it is we have been able to create a simple image recognition model that essentially is able to predict whether we are having an image of the water bottle or image of phone. And you can actually go ahead and directly just export this model if you want to utilize this model. And as you can see that within TensorFlow.js, you can export it with JavaScript. And over here, what it does is that it will basically output a model.json file. And essentially that contains all the details about this model. And again, very simply, what it does is that again, in this async function, where it is actually initializing the model, we are just calling our model.json file that contains the information about the model that you have just created. And then it is opening up your webcam, and it is getting the feed from your webcam, and then it is using the feed from your webcam from this webcam.canvas, and actually passing the prediction through that webcam feed that it gets to be able to predict what is the actual class. So in this case, it was trying to predict through my webcam feed whether I have a water bottle or a phone, and it was trying to predict that particular class. So you can see that how amazing and how simple it is to be able to actually go ahead and utilize the TensorFlow.js, and especially being able to actually retrain this model. And you can just utilize this for your own benefit. Now, of course, if you want, if you are let's say if you have knowledge about let's say deep learning, you can correlate to some of these different things such as epochs, batch size, learning rate. These are some terminologies that we actually use within neural networks, within deep learning. So if you are well versed with these terminologies, then you must be aware of, and so essentially you can actually go ahead and then tweak these settings as well to create a more customized machine learning model. So whether it is trying to have more number of training cycles, trying to increase or lower the batch size, you can do all of that. And if you want to see actually what's actually going on behind the scenes, like under the hood, you can actually see some of the more in-depth machine learning things like the confusion matrix. Again, we'll not be going too deep into all of those, but again, this is just in case you are interested to learn about these concepts. You can actually do that with the help of this teachable machine. So I'll just share this link with everyone. Just a second. All right, with Google, my bad. So I'll just share this over here. So in case you are interested to actually go ahead and try this out, feel free to actually go ahead and do so. All right. So I just saw this one question that was, hey, could you please sharing the same screen? Oh, okay, sure. I hope that was good now. I hope that didn't cause much issues. All right, perfect. So again, if anyone has any questions, feel free to ask. You can type up your questions inside of the chat in case you have any questions. So going ahead, right, as we described that this is of course one of the ways of being able to actually use some existing models and then retrain those models on your own data. And of course, some apart from that, if you have let's say data in millions of images, you can also use something known as Cloud Auto ML to be able to evaluate data, which if in case you have a lot of data. Now, one of the limitations of the teachable machine is the fact that it is limited to how much amount of data that you can actually do, because it is actually doing all of this machine learning inference on the browser itself. So there are certain limitations to how much data you can actually utilize to train. But if you have let's say production data that has million items, million images, you can actually use the Cloud Auto ML that is available on let's say GCP, the Google Cloud Platform. Now, of course, this is just one of the sample code that we have already explored, but we'll be going deeper into one of the projects that we have created for this for the demo. But of course, coming to the final place that if you want to actually go ahead and write your own code, so you can actually do that with the help of TensorFlow.js. So in order to do that, there are essentially two different ways in which you can create or write machine learning models directly within JavaScript. So the first one being the high-level layers API. So in case if you come from a Python background, especially from a TensorFlow background, within Python you must be aware of Keras, which is high-level kind of a high-level layer on top of the TensorFlow itself, which provides you certain functions using which you can create machine learning models. Or if you let's say are really well versed with the mathematics involved and you want to tinker around with let's say the linear regression, neural algebra within machine learning, you can use the low level ops API. So you are provided with these two different set of APIs that you can use within your JavaScript code to create your own machine learning models. So what we have actually learned so far is that at the top, right, we have the pre-existing models. Then we have the layers API that essentially provides you a wrapper around the core mathematical functions, and at the base you have the core. This is where you can really tinker around with anything that you want. And the best part is that you can actually run machine learning models both on the client side. When we say that what is the client side, that is actually on the browser itself. Or let's say if you have a dedicated Node.js server, you can also run machine learning models on a Node server. And of course, some of the examples that we saw were the Keras model. So the TensorFlow Save model is what essentially is the low level API. And within, when we talk about let's say the client side, there are multiple backends. Now, don't get confused with this backend as let's say backend language. It's just basically that you can select which particular type of a tooling that you actually want to run your machine learning models. So usually whenever we talk about machine learning, right, there are of course, since it's very computationally heavy, right, it does require you a certain set of computational resources. So that is why we have essentially a number of different ways in which you can actually optimize the performance of machine learning models. Now, the bare minimum that we have is the CPU. So essentially, it is going to be utilizing the CPU that might be in your in your phone or in your computer. Now, there are some other methods that are currently supported, including things like WebAssembly and WebGL, which allow you to actually communicate your browser. So, if you're not aware, JavaScript has certain APIs, browser APIs, that allow you to actually communicate directly with your system hardware. So you can actually utilize the system resources, your actual computer system resources, such as your GPU and your CPU, to basically further optimize the performance and boost up the performance of your machine learning models. So you have these separate different type of supported frameworks and that you can actually use. Some of the other ones that are also being tested include right now WebNN and WebGPU. So if you do explore the TensorFlow.js repository that we'll very soon take a look at, there are machine learning models that are supported for all of these different type of backends. And again, you can utilize one of your choice and use them to create and be able to actually implement machine learning models. And then if we compare in terms of just the performance, right? So here is an example of the mobile net, which is used for image classification, and you can see that in terms of how much time it actually takes for executing the models, you can see that for TensorFlow.js, it is actually very it has actually better or very comparable performance with let's say your traditional Python based machine learning models. And one of the reasons for that is that within specifically like Node.js, it uses just in time compilation. So that helps for improving the performance of your applications. And actually, in some other examples, TensorFlow.js models actually just perform way better than your normal Python based models. And one of the questions might be that, okay, why should you actually utilize TensorFlow.js or why should actually use TensorFlow.js on the client side, right? So the biggest one being the privacy. So usually whenever if you had to do a machine learning inference, you will send your data to a remote server, and while you're actually sending your data, you're communicating your data. Then of course there can be times when there could be a network disruption or it could be hacked. Now, when you're actually running a machine learning inference on your browser itself, then what's happening is that you're not actually sending your data anywhere on the internet. Everything is locally in your system. So your data is actually very you have a lot of privacy of your data. It also ensures that you have lower latency, so you don't have to wait for the network response. Everything is happening localized in your system. You'll have lower cost as well, because you don't have to pay for dedicated resources, dedicated server cost. But of course, there are some other benefits that are dedicated just for being able to actually run machine learning models on the server side. And some of them being that in case you have much more highly computational models, then you can use dedicated server resources that allow you to run larger models on the server side as well. And of course, you get the performance benefit of Node.js that can be used to run these machine learning models. Now, of course, before we move to the resources, because that will be the last section, we'll look at some demos that actually can actually get you started with using TensorFlow.js. But till then, again, if you have any questions, feel free to ask. Of course, George, the recording will be also live on YouTube. So once the basically our once the session gets end, the recordings will be live on YouTube as well. But again, in case you have any questions so far, would love to know. Otherwise, we'll move to the implementation section. So Abhishek is asking that the syntaxes are so long to learn and understand their functionality. Abhishek, I'm not entirely sure if you mean that. Do you mean the syntax for the teachable machine, or in what context? I would love to know your feedback. So G's saying that I like playing pool, and I would want to train data to see the body mechanics when I make my shot and when I miss. what is the body mechanics program? When I train, can I tell whether it was successful? So absolutely. So one of the different things that you can actually do is that you can actually, let's say, create two different types of classes. One is where you actually train your machine learning model that what exactly is a successful shot. So let's say if you're let's say playing pool, so a successful pool action would be that if you hit the ball and the ball goes in one of the holes at the corner of the table, and you can actually train that to your machine learning model when then that particular action actually takes place. Now, of course, to be able to detect that okay, it was not successful, is that when you hit the ball actually does not actually go into the into one of the holes. So Abhishek is asking, like, while using TensorFlow.js models, the syntaxes are too long to learn as a beginner. So Abhishek, again, as I described that, especially if you're getting started, if you're just getting started with TensorFlow.js, one of the great ways that I'll recommend is to look at some of the pre-existing models, because these are you just need some basic JavaScript knowledge. So you just need to know how you can create simple functions in JavaScript. So the only prerequisite is JavaScript itself, and you should be good enough to get started with some of these simple machine learning models that are actually there. So I hope that answers your question. But of course, in case you want to extend your knowledge, then you can also take up some courses within TensorFlow.js. I'll be sharing a link of some of these courses that are provided by the TensorFlow.js team itself. So again, I'll recommend to all of you to just stay tuned for the next 10 to 15 minutes as we complete this entire session and we move towards the resources section. So I'll now like to move on to some simple examples. So this is a very simple example that I wanted to create again using the Coco SSD model. So over here, what I've just done is I've just created basically a very simple Coco SSD object detection model. So over here, what I'm going to be doing is I'm just first showing you the demonstration. So I'll click on upload image and I'll just upload image of a random image. Now what you can see is that as soon as I upload this image, I get the result instantaneously, right? And what you can see is that I have this image of this of my friend, and over here you can see that it has basically created these bounding box. So on the human, it has been able to create a bounding box and make a prediction that it is a person. Then over here, although this is actually a glass, it looks like a bowl, so it has predicted that this is a bowl, and this is a dining table. So automatically, this CocoSSD model has been able to detect the classes and three different classes of a person, dining table, and bowl. So if, let's say that of course, I mean, to first eye, this might look like a very complex function, right? But let's actually go ahead and explore this particular this particular file. So first thing that we have done is that we have basically within our simple HTML file, we have basically imported two different scripts, right? So essentially these are CDN links for the TensorFlow.js itself and the Coco SSD model that is provided within TensorFlow.js. So if I go to the CDN link, this is of course the entire TensorFlow.js function that has been provided, and I'm just simply importing them within my index.html file. And since we are actually using the Coco SSD model, we are also importing that. Of course, in case now you are using, let's say, a React project, a Vue project, Angular, you might install the recommended npm module. So you'll also have the corresponding npm modules for TensorFlow.js and for the Coco SSD model that you can actually use. And over here, we have simply just what we're doing is that we have initiated a canvas. So this is the canvas where our image gets uploaded, and we draw the bounding box on this canvas, and we just create a simple upload image function. And of course, we have a dedicated JavaScript file, which is the index.js. And we'll just simply understand what's happening within this index.js file. And I'll, of course, just increase the size of the file. So over here, what you can see is that initially what we are doing is that we have basically this particular function. So what this is doing is that since we have imported the Coco SSD model using this CDN, right, we can actually call that function within this is a function that is provided to us within our JavaScript. So we are using the CocoSSD.load function. So why this particular line? Because since we are essentially calling an externally hosted machine learning model, we are basically loading that model inside of our browser. So if I open the inspect element and if I go to my console, or just go to my console, and if I just refresh, right, you can see that it says that the model is actually ready. And actually I would like to go to the network tab to see when my model actually loads, right? So as you can see that over here, my model .json, this is the actual model, like the Coco SSD model that has loaded. So what happens is that my web application will wait. It will wait for the network response for the actual model to be downloaded and then loaded for my web application, right? So it just waits for, like, let's say less than a second. Again, in case your machine learning model is probably a bit larger, then it might take a bit more time to actually load it locally inside of your browser. So that is what is happening inside of this particular function, that we just wait for our machine learning model to load so that we can actually start utilizing our model. Now, once we have actually gone ahead and we have loaded our model, we are invoking our upload function so that you can basically upload an image and then try to find out what predictions you get using the Coco SSD model. So this is the function for uploading an image. So again, what we do is that first of all, we call the function over here where we basically go ahead and upload the image. So we'll take the local image from our file system and we use that over here inside of our upload image function. And then what we do is that over here, what we're doing is that once the image has been loaded and we have gotten and our JavaScript function has been able to get the file, the image that we have gotten. Over here, what we're doing is that this is the sort of the main brain of our entire JavaScript function, right? Over here, what we're doing is over here within this particular line, that is line number 34, using our Coco SSD model, we are trying to first of all detect within our image, right? So the image that we have given, that what exactly are the certain predictions that we actually get within the image. And we are actually doing two things. We are calling this function drawRes, which is defined over here. So essentially what we are doing over here is that on the image that we send as our input, we are basically drawing those bounding box that you can actually see. So if I select an image, let's say go ahead and actually select another image, just select this particular image. So let's go ahead and select this image. So the basically this blue colored box that you see around, this is what we are actually drawing on top of the actual existing image. And this blue colored bounding box is defined over here where we are actually creating a bounding box. And the way it is actually able to get that is by looking at the if you see over here the B box. So these are the coordinates of the bounding box. And how is it actually able to get these is by the prediction. So if we very carefully see over here, you can see that we get three different type of predictions, and you can see the bounding box coordinates. So essentially what it's giving to us are the coordinates within the image that we have provided to it, coordinates within the canvas, where the machine learning model is actually able to predict these coordinates. So for example, for instance, the first one is the person. So the boundings, the coordinates that we get are 127, 94, 307, and 281. So they're essentially these coordinates, x, y, x1, y1, right? So 127, 94, 307, and 281. And these coordinates are then passed to our bounding box drawing function, and it takes these coordinates and draws this rectangular or this square icon. So what we are actually getting from the response from our machine learning model is the class, that the predicted class. Then what is the score, that okay, how much confident. So essentially in this case, the machine learning model is 98% confident that there is an image of a person inside of this particular frame. So if we just try to, let's say, have a hot dog. So I'll just download an hot dog image right now, and let's try to see if our machine learning model is able to actually predict. So let's just go ahead and download this image. We'll just go ahead and save this image, and we'll try to see if it is able to predict it. So let's go ahead and upload this image. So as you can see that, again, in this case, it was able to detect 4 different items. Again, hot dog, and then bowl. You can see the prediction score, the bounding box coordinates where it finds out. And that's what we are actually utilizing this particular function for. That from the predictions that we get, it gets the coordinates that we want. And then it creates, basically, since we are using the canvas, we are using the ctx.stroke_rect to actually create like a rectangle on top of it. And then we are also using the function draw label to actually draw the label. So label is what you see over here, like the bowl or the hot dog, and that is what we are getting from the class. So that is why we say that what we are filling the text with is the prediction.class. And in case of if you wanted to draw the bounding box, it was the prediction.bbox. And then, of course, since we have an array, we are just utilizing the 0, 1, 2, and 3. That are the 4 different bounding box coordinates that we get. And that's what we're creating. So again, you didn't require any type of knowledge of the mathematics. So if you just see the mathematics behind the Coco SSD model, right? Mathematics of Coco SSD model. Of course, we didn't have to know what exactly is the mathematics behind the Coco SSD model that is actually there, right? So if we just go through this towards data science function, right? We didn't have to learn all of this architecture that usually is revolved. So this is an example for a VGG architecture, which is a deep learning system, right? So we didn't have to know what exactly is convolutional. I mean, even I personally, since I've been slightly out of touch with deep learning, I do know what's happening behind the scenes. But of course, for someone who might not have experience, does not need to know anything about this. You simply just need to call the model and utilize it within your JavaScript function and simply call it. So that's what you can. That's the power, because the majority of the things that we are doing over here is majority of the code that we are writing is JavaScript code, right? The only things that that are related to machine learning are really just this detect function and then trying to predict what we are actually seeing inside of the function. So I hope this gives a little more insight into how we are be able to actually just very simply within 5 to 6 lines of code, you're actually able to create such amazing applications, right? So you don't need any kind of prerequisite knowledge about mathematics, about TensorFlow, about machine learning, and very simply you can utilize these machine learning models within JavaScript. Now, just as a vote of hands, how many of you actually come in from a Python background, or have you explored, let's say, Keras, TensorFlow within Python? Would love to know from the audience that is currently watching live. Would love to know how many of you have been utilizing Python, or have you been creating machine learning models in Python? So Abhishek has been using OpenCV. And again, just as a reminder, if you are actually liking the session, I'd highly recommend take a screenshot of this session and share it on, do share it on Twitter, and you can tag me if you want, and tag others. So feel free to go ahead and invite others and share about this session with others. So a few of you have mentioned that you're you utilize MediaPipe, you use OpenCV, you have used sklearn. So the next example that I just wanted to show all of you is that let's say that you are coming in from a core Python background. So over here I have a Keras Keras function where basically I have taken a Pima Indians diabetes dataset. This is a dataset that basically contains data of women and their age, and the main aim is to try to predict whether a person will is at the risk of getting diabetes or not. So over here you can see that we have basically defined a deep learning model. Again, no need to really go over all these terms. These are mainly when we are actually defining our actual structure of our deep learning model. We have defined some activation functions. We have defined the cross and basically binary cross entropy to be used. Again, no need to really understand what is happening over here. Essentially, what we have is a Python function, and we are simply just utilizing this Python function over here that is used to do this deep learning training. And we are simply going ahead and doing our prediction. And finally, once we do the prediction, we are saving our Python based machine learning model. And usually, if you're aware, if you're dealing with Python based machine learning, the the file format in which we save it is usually .pickle file or a .h5. Now, since we are talking about that, you can actually convert Python-based machine learning models into JavaScript models. So for that, that is where basically we use something known as the TensorFlow.js converter. So for that, we basically just install the Python package for TensorFlow.js, and we simply use this command where we provide that, okay, what is the output format in which you actually need your file, and we give the input Python-based machine learning model file to this converter, and it goes ahead and converts your Python model into a TensorFlow.js model. And the end result is that you get this model.json file. And as you can see that over here, you can see that it has been converted by the TensorFlow.js converter. It has some details about the what type of model it was, and information about the classes. And then it also creates this group shard 1 of 1. This is essentially your machine learning model weights, right? And you can simply then go ahead and utilize them inside of your JavaScript function. Again, over here, what we are doing is that we have basically again defined a JavaScript function where we are basically utilizing this function known as tf.load layers model. We are basically where we are loading this model.json, and then we are using some again specific TensorFlow specific functions to actually be able to predict so these are basically all the different type of input arguments that we are taking inside of our machine learning model, things like pregnancies, glucose, insulin, BMI, age, to try to predict that whether this particular person is at the risk of getting diabetes or not. And again, we are simply just having a very simple index.html. We didn't require to know how was this model created, right? Again, all of this complex Python function, we didn't really have to do anything with it. The only thing that we did was call this function inside of the model.json file, invoke it, and use it, right? So of course, these are some of the examples where we are going ahead and just utilizing the already existing models, and we are trying to do. So the end result would be that I'll just close this function and I'll go live with this. So the end result would be that over here, I'll just put in some values, and finally, when I submit, the end result would be that I'll basically get a prediction whether a person with all of these different values, whether they are at risk of getting diabetes or not, right? So that's another example that I just wanted to show all of you. So I hope that this gives a sense of understanding that how easy it is actually to get started. But of course, I'll come to probably the most interesting part is of course the resources. So in case you are interested to get started with TensorFlow.js, these are some of the resources that you can take a look at. Again, what I'll recommend to all of you is take a screenshot of this particular slide and do share. You can tag me if you want. My Twitter handle is howdevelop, but just go ahead and just share about the resources from this, right? So we have the official TensorFlow.js website that we that we just explored. So if you want to see some guides, some tutorials, you can actually go ahead and see some of these. And if you actually want to see some live working demos, you can also explore this as well. Then we have the official GitHub repository. So basically, since this is an open source project, we have the entire it has over 16.4 k stars. So it is a completely open source project as well. And if you want to explore, if you want to contribute, you can go ahead and contribute as well if you're interested to do that. You can also look at some examples on websites like CodePen and Glitch. And one course that I'll definitely recommend to all of you is this Zero to Hero TensorFlow.js course. This is an official course by the Google TensorFlow team, and I'll definitely recommend to all of you to explore this if you have learned anything from this session, and if you are interested to go ahead and learn. This is a free of cost edX course. Again, you learn from the very basics of machine learning all the way to be able to actually create full stack applications with machine learning. So I'll definitely recommend this particular course to all of you. Again, if you are interested, do go ahead and recommend this course, and again share on Twitter about this course to everyone that you might be knowing. So these are of course some of the courses that you can take a look at. And then of course the idea is that the TensorFlow.js community is a really fun one, right? You can see all of these different fun applications that you can build. So we have a special series on YouTube, which is YouTube made with basically made with TFJS. Over here you can get inspired by looking at some of the different type of applications that people have actually built. So actually one of my projects got also showcased on the TensorFlow.js show and tell. So if you are interested to check that out, you can also look at this show and tell number 3. But the idea is that you can get inspired to see some of the amazing projects that people are actually building. So for example, this is one of the projects that was showcased on the official TensorFlow channel, where I actually created my own physiotherapy assistant using TensorFlow.js. So if you are actually interested to build a project of your own, you can get inspired by looking at some of these demos. So I'll definitely recommend to also check this out as well. Yes, I'll definitely share. Yeah, let me just put up the slide for the course, because this specific course, this particular slide, this specific course basically takes you through the entire journey of even if you're a beginner within machine learning, you'll be taught machine learning that is relevant for TensorFlow.js, and you'll learn the basics of TensorFlow.js. You'll basically create a number of different projects, right? You'll learn TensorFlow.js from scratch. So I'll hugely recommend to go and sign up for this course today. It's free of cost. If you want to get certified, of course you can pay for it, but it's completely free of cost as well. So I'll definitely recommend this course to everyone. And of course, as I mentioned, that in case you are interested in joining the TensorFlow.js community, just you can follow the hashtag made with TFJS on on GitHub, on Twitter, on LinkedIn, on YouTube, and you'll find a number of different great resources to get started with. And of course the main idea is that TensorFlow.js was made with with the fact that even if you have no knowledge of TensorFlow.js, of machine learning, even if you're a beginner, even if you're a student, you can create very fun use cases with machine learning. And the main idea is that machine learning is not to be scared of, right? You don't need to be a PhD in mathematics to get started with machine learning. Even if you're an absolute beginner, you can get started with machine learning. And even if you don't want to learn the core basics, you can actually implement machine learning within, let's say, JavaScript, or even cross platform applications with creating Android, iOS applications with let's say React Native. So that's the main part. And of course now I am open to questions. Again, these are some of the resources that you can take a look at. You can join the discuss as well if you have any questions. And we also have basically a we also have a Discord as well. So if you want to join the Discord, I'll be more than happy to share that with you as well. But yes, now I'm actually open to questions. So yes, Abhishek, there is actually a Discord. So let me just grab the TensorFlow.js. I'm not sure if I have that handy, but let me just grab that Discord server. I think there should be one. So all of you can actually join the Discord server. It is a very fun way. Let me actually fetch that Discord server link for all of you. So I'll just go to discord.com and I'll just quickly go ahead and open up. So I'll share the link for the Discord with all of you. So this is the official TensorFlow.js Discord. Let me just go ahead and share this with everyone. Let me see if I'm able to share. All right. Oh, okay. So let me just quickly go ahead and share this. Just give me 1 second. Just a second. All right. Let me share this invite with all of you. Let me see if it is readily available. Let's see. All right. Invite people. All right. Yeah. So I've gotten the link. Let me just share it with everyone. All right. So all of you can actually go ahead and join this Discord in case you want to stay tuned, and if you want to know about TensorFlow.js, you can communicate with all 500 plus members that are already part of this, and you can join this Discord as well. And then before we leave, I'll just also share the slides link with everyone. I'll be basically going ahead and sharing this with everyone, of course, on the official Codementor. So let me just go ahead and actually copy this link and paste it on the official Codementor site. So in case anyone is interested to refer to the slides, I'll be also just posting the code that we have actually shared today. I'll be posting it on GitHub, and I'll be updating the Codementor site. But of course, if you are interested in communicating with me and connecting with me, you can connect with me on my Twitter. So my Twitter handle is howdevelop. In case you have any questions, I'll be also there actually on the Discord for TensorFlow.js. So you can ask me any questions. In case you have any questions on TensorFlow.js, you can connect with me on the Discord, or if you are interested to connect with me on Twitter, would love to do that. At the end, of course, what I would like to do, request everyone is, I'll quickly just go ahead and go to this particular section. So I just have a very special request for everyone. I'm actually stopping this particular screen share, and I'm just sharing this again. For those who have still decided to stick at the end, if you are comfortable enough, I would love if you can actually go ahead and open up your camera if you are interested. I would just like to take a screenshot of this entire session for those who have been here for the past 1 hour so if you are comfortable, would really just encourage you to open up your camera, and I'd love to take a screenshot of today's session and share it on the publics. And I highly appreciate so many people who have joined in and are still there. So I think we can probably just do a victory sign or whatever kind of action you want to do. So I'll just quickly take a screenshot, and I highly appreciate everyone who today is actually appearing in today's session. So let me just quickly take a screenshot. Just a second. All right, perfect. And I'll just quickly go ahead and save this as well. All right, perfect. Thank you so much. Oh, by the way, a number of more people actually opened up their camera. So let me actually just go ahead and take another screenshot. just a second. All right, let me just quickly take another screenshot. Just a second. Okay, for some reason this doesn't appear to work. All right, yeah, second. Let me just go ahead and take another screenshot. Thank you. Perfect. So this is really useful. Thank you so much to everyone who has joined today. But in the end, before we leave, I'll just like to again share some additional resources. And again, in case anyone, if you have any questions now, since we are towards the end of the session, feel free to ask any questions from today's session. And in case you have any feedback, would love to hear that as well. In case you have any feedback from today's session. So at the end, if you have any questions, feel free to ask. So of course, probably one of the questions that you might have is that, what's the next steps? So of course, if you want to get involved with TensorFlow.js, again, I will recommend to all of you that to get started, you can basically go ahead and learn the basics of JavaScript, and again, take up that course that we shared, right, with everyone, and the TensorFlow.js course. Now, if you're still there for another couple of minutes, we have a fun segment to this session, and we have a couple of couple of quiz questions, and I will be giving away basically a coupon for a book for the TensorFlow.js book. Now, I'm not sure if I have that book handy over here, but basically, I'll be sharing a coupon for a O'Reilly book. So, in case if you are interested, you can stay behind. But I have a couple of questions that, I'll ask. So, basically, the first question is, what are the types of APIs provided by TensorFlow.js for writing your own code? So for the third type of way in which you can actually write, we had two different types of APIs: the low level API and the high level API. So if any one of you can actually, if you remember them and you can answer them and answer them correctly, I will reach out to you over Twitter, and I will share a coupon code with you for a TensorFlow.js book. So it's a really cool book. I'll be sharing the details with that. But if anyone remembers, you can put that into the chat section. So if anyone remembers the two different type of APIs. Yeah. So basically, Abhishek, in case you answer this particular question correctly, you'll be getting a coupon for a TensorFlow.js book, an O'Reilly TensorFlow.js book. So you're getting a free coupon for that. And I'll be sharing that with you over Twitter. So if anyone remembers, we had discussed about two different type of APIs, the low level API and the high level API. So if you remember the names of those, you can add. So Kavita, Keras is for Python. You have to so basically, if you remember the layer API and what's the other one. So I have given a hint for layers API and what's the other one. So one was the layers API and the other one was the dash API. So anyone who can answer that will win this one. Will win this round. So I had shared, in case you want to create your own machine learning model in JavaScript, there are two different type of APIs. One is the layers API, and what's the other one? Yes, so Kavita actually gets that one. So as we had discussed that, there are two different type of APIs. One is the layers API and the other one is the ops API. So you basically get two different type of APIs. So Kavita, please share your Twitter handle, and I'll be sharing the price. Basically, I'll be sending over the coupon with you. So if you don't mind, please share your Twitter handle. I'll communicate with you over Twitter. All right, perfect. Or if you don't want to share it publicly, you can message me on my Twitter. I'm just sharing my Twitter again on the chat section. Now, coming to the next question. The next question is, what are the different types of models that are provided by the Teachable Machine? So if you recall, I showed an example for the image model, but there are two other types of models that the Teachable Machine provides. So if you can answer that within the chat, again, you'll be the winner for this round. So currently there are three different types of models that are supported. The one example that I showed was the image model. There are two others that you can actually use. So what are the two other ones that are there? Sound? Yes. So Abhishek, one is audio and poses. So that prize goes to Abhishek. So again, Abhishek, do please message me on Twitter, and I'll share the coupon code with you. Now coming to the final question, what are the two main benefits of actually running TensorFlow.js on the server side? What are the two main benefits? So this is for those who haven't answered yet. So what are the two benefits of actually being able to run TensorFlow.js with Node.js? So we had looked at a number of different advantages of actually running TensorFlow.js on both client side and the server side. So what are the two different type of advantages that we have? All right. So I think you get this answer that you get more security and more processing power. So that's correct. So you get the third prize. All right, perfect. So with that, that's the official conclusion. And by the way, the winners will be getting this particular book. Let me actually share the O'Reilly TensorFlow.js book. So this is actually the book that you will be receiving. This is the book. You'll be getting essentially the e-version or the e-version of this book. So this is the book that all of you will be winning. To the winners, again, feel free to message me on Discord. on Twitter, and I'll be reaching out to you as well. So let me just quickly grab these links and put them across over here. All right, perfect. So again, thank you so much to everyone. I really thank everyone who in today's session. And again, you can always reach out to me in case you have any questions. Feel free to tweet about this session, and you can start with that course on TensorFlow.js. With that, thank you so much, and we'll be concluding the session now. Thank you very much.